Hello students, in the last lecture of unit number 4, we discussed the introduction to the programmable logic controller, architecture of the PLC, then the different components of PLC like input module, output module and memory, and the communication system like address bar. Now in this unit we are going to study the different types of PLC, then ladder logic implementation for different types of logic gate, that is AND gate, OR gate, then what is meant by latching circuit, timers and counters, and a practical example of ladder programming. So let's start. So types of PLC. So single box PLC, or sometimes it is referred as brick. It is commonly used for small programmable controller and is supplied as an internal compact package complete with power supply. So typically it has the input up to 24 input and 16 output, and can store the some instruction like from 300 to 1000 microns. 300 to 1000 instructions. Modular. The modular or rack type consists of separate module for power supply, processor, input module, output module, and memory. So simply, these are the types of PLC. You can see the difference. Physical, the brick type, a single box type PLC will look like this, and the rack type will look like this. So as I said, in brick type we have the input channel and output channel only, but here for each module we have the separate channel is defined as given. Now the operation mode in the PLC. So there are two modes, the input output scan mode and the execution mode. So the input output scan mode, the processor will update all the types of input and output that we are connected to the one channel, and the time required for this, that will depend on the speed of the processor. That means what are the devices that we are connecting the input module and what are the devices connecting the output module, this information will be gathered or collected, processed by using this input output scan. The execution mode, the set of instruction. Set of instruction means what? The sequence of activity which is defined in programming, that is evaluated, executed in this particular run. So that sequence of activity may include, or to develop the sequence of activity, you may have some logical conditions. So based on that, the rung will be evaluated in such a way that the relay contact in the rung is considered, and if the true is path, the output device is detected, then output device is energized. The meaning is simply that if the input device it is in the close condition, on condition, then your respective output which is connected in that rung will be in the off condition. And at the end of ladder diagram, the output mode is entered again, and all output devices are provided with on-off state to determine execution of ladder program. So all the inputs are sampled and the execution modes will start again. So the process will repeat as per the sequence. Now the PLC addressing. So generally while developing the ladder diagram will require this addressing. So the input channels are addressed like from 00 to 07. Output channels will be addressed from 08 to 15. Internal relays will be addressed from 16 to 31, and timers and counters will be addressed from 30 to 39. That means whenever you are getting the 0, 0, 0, 1, 0, 2, 0, 3, 0, 4 up to 7, so that indicates the input channel or input devices. Output devices, that is nothing but from 8 to 15 and so on. Now in programmable diagram interpretation, on off state of the output rung is determined by testing element of the rung for true or false condition. If the complete true element path to the output exists in the rung, then output will be made of true or on. So as I said, if the input device is in the on condition, actuated condition, that is equivalent to the on, so you can say true condition of the your particular sequence, and accordingly the output module will be energized. The symbol for, so see here, so what is true and what is false? So the symbol for normally open contact, that will indicate the false condition, or and if the condition is found on, examine on, then it is a true condition, so this is the on condition, right? The symbol for normally close contact indicates that if it is tested around found close, means suppose there are some devices where you will have to use the normally close contact. So earlier mode, that is nothing but their close mode is the false and their open mode is the true. That is the exactly opposite condition that we are calling, or that we have discussed in the first condition. Means there are two types of contacts which normally open and normally close. So those are normally open. For them, normally open is the false condition and normally close is the true condition. But those who are normally close, so close is the false condition. Their default condition is always close. But when you have some input, some power supply, then it goes to the open condition. In short, it is referred to the on condition. So it is just a difference between normally open and normally closed. So here, use of normally closed push button switch to turn on the red light. So simply here the normally closed type of switch is used. So what is the meaning here? In the first A diagram, there are two vertical lines. In this vertical line, power supply is there. So the power will going to flow from this side to this side through the rung. Now in this rung, as the switch is normally closed, so the power straightly flow and your red indicator will get the supply and it is glowing continuously. Now in the second, so here whatever I am saying for normally closed, so normally closed means here what? It is a false condition, right? But when you open, it's true condition and that will result into the off state of the light. While in the second diagram also we have seen that push button is normally closed, contact relay is energized by default, and because of that their contact is also energized, and the relay will be in the, this red light will be in the on position. So just by using the relay we are going to have the control on and off of the light. So here normally close push button state at normally closed condition. Normally closed means what? It is a false, it is their default position. So when you actuate it, it goes to the open condition, that is the true condition, that is the off state of the light. And as we said, addressing information, so here in the form of addressing information we can develop the ladder diagram, like as I said, input devices from 0, 1 to 0, 7. So here first we'll label at 0, 1, output input device. Output device will address from 8 to 17. So first one, that is starting from 8, so here it is defined by the 8 one. Programming of the ladder. So ladder logic used for machine control, functional block diagram for the process control, and as simply it will look like a ladder, we call this as a ladder diagram. So this is the graphical representation. Generally, what is my ladder diagram? It is a graphical representation of sequence of activity for sequential controller. So two vertical lines, these are the power supply line. Horizontal lines, they are called the rungs of the ladder. And as I said, on the left half, that means on the half of the left portion, here we are going to connect the input devices. On the right half, we are going to connect the output devices. You see here, as I said, input is nothing but on the left half, output is nothing but in the right half. Elements of ladder. So input, that may have switches, normally open, normally close, contacts of relay, right? And the output devices, that is nothing but your motor, solenoid valve. These are the different types of switches as well as sensors contact. Here we'll see pressure, temperature, level sensor. Here, so that these are the different types of switches as well as sensors contact. Here we'll see pressure, temperature, level sensor. Here, so that similar here, so that here.